In this lesson, we're going to talk about the R-squared value. So previously we talked about the correlation coefficient, which of course was R. Obviously, R-squared means I'm going to square that correlation coefficient. It's often called the coefficient of determination. What we really need to know is what exactly does R-squared mean? Well, it obviously is always between 0 and 1, or as a percent, 0 and 100%. And it gives the percentage of variability that is accounted for by the model. So essentially we're saying the model will take into account whatever percentage of the variance of the y value. So I'll show you an example in just a minute. It essentially is giving us how strong our model is. The closer that we get to 100%, obviously the more useful our model is. So let's take a look. Here is the variation of residuals for the fast food chain and for fat. So for the residuals and then the box plot for fat. R is 0.76, which is calculated for us. R is 0.76. I can compute R squared very easily by, of course, squaring 0.76, which is 0.58. I would then write this as a percent. So I would say that this tells us that 58% of the variability in fat content, so 58% of the variability of fat in fast food is accounted for by the variation of the protein. So remember when we did our scatter plot, protein was here and fat was here. So we're saying 58% of the changes in Y are accounted for by the changes in X. So adding more protein will affect the fat, but only 58% of the fat increase or decrease is based on that protein. This means that 42% of the variability is based on other things, like how the food is prepared, etc. So only 58% of it is accounted for by the variation in protein. Here's an example using pressure and maximum wind speed. So again, our R squared value is 0.773. That means that 77.3% of the variability in maximum wind speeds of a hurricane is accounted for by the variation in pressure. The 100% minus that, or 22.7% of the variability in maximum wind speeds, is left to the residuals. So things like temperature, location, etc., that accounts for the other variations in the wind speed. A couple of questions I want you to think about. So I want you to press pause and try both of these questions and then press play to check your work. For the first, it says, is a correlation of 0.9 twice as strong as a correlation of 0.45? So this is saying R is 0.9 and R is 0.45. Well, if we're looking just at the correlation coefficient, yes, obviously if I took this times 2, I get 0.9. But we're talking about the strength, which means we're actually looking at R squared. So what I would do is, of course, square 0.9 and square 0.45, and I can see that actually this is 4 times as strong as the 0.45. 4 times as strong. What would be the correlation of a least squared regression line that accounts for half of the variability? So if it accounts for half of the variability, that means R squared is 0.5, which means the square root of that, which is R, would be 0.7071. So half of the variability, 50%, take the square root.